Okay, so hello and good afternoon, everybody. So for today's meeting, we will just be continuing where we left off last meeting. So last meeting, we have introduced this method or the simplified method of analysis, and I have already shown you on how to interpret these conditions and these locations. And for this meeting, we will be having an example, I should say. So we will be having an example for you to understand our lessons better. Okay, so for our example, so ito yung example nating una, no? So a continuous beam is to be subjected to a total uniform dead load of 15 kilonewtons per meter and a live load of 24 kilonewtons per meter. So naputol lang per meter talaga to. Teka, ayusin na nga lang natin para maayos. Okay, so kilonewtons per meter. So determine the factored shear and moments of each segment. So what we will be doing here is that we will be getting the moments at midspan and the shear, moments at the midspan and at the ends and the shears of it. Okay, so once again, we will be making use of this table. But can I get a confirmation? Are the values readable or hindi? Kailan ko lakihan? Is it readable or lakihan ko, guys?
Sir, nababasa naman po.
Okay, sige. So, para lang sure, though nababasa, onting-onti lakihan ko. Okay, so ayan, para mas maayos. Anyway, so what we would be doing is that we will be applying these factors or these formulas for us to get the shear end moment of this continuous beam right here. So the first thing that we will be doing is that we will be getting the factored load first. So we have your uniform dead load. So for your dead load, kapalan natin, no? So WDL, so this is to be the uniformly distributed dead load, and that is to be 15 kilonewtons per meter. And we also have our uniform live load or WLL, and this is to be 24 kilonewtons per meter. Okay, and with such, once again, we will be applying our load combinations already. So, ito yung gagamitin nating load combinations as per NSCP 2015. So, there. So, we will be using all of this if applicable. But the thing is, we do not have our earthquake load. So, we do not have our earthquake load. We do not have our wind load. And we do not have our roof live load. So, ang natira na lang is to be dead load and live load. And if that is to be the case, if your loads are only dead loads and live loads, we will only be using this. Itong dalawa lang gagamitin natin. So 1.4 dead load and 1.2 dead load plus 1.6 live load. So wala din tayong roof live load, by the way. Anyway, so proceeding. So once again, we will be getting the factored loads of the first combination, which is 1.4 dead load, I should say. So ibahin natin yung kulay para mas kita. So for our WU or ultimate load, that is to be 1.4 times dead load. And for the second factored load, that is to be 1.6 dead load. So DL na lalagay ko plus 1.6 live load. So we will be solving for both of these and we will be checking which one will govern. So the higher the magnitude, the more critical it is. So the more critical it is, yun yung mag-govern. So ayun. So for the first load combination, that is basically 1.4 times dead load. So looking at the calculator to your left, so hindi ko na isulat, that is just 1.4 times 15. So 1.4 times 15 would give you an answer of 21 kilonewtons per meter. So 21 kilonewtons per meter. So there. And as for the second one, which is to be this, so that is to be 1.2 times dead loads, and our dead load is 15 kilonewtons per meter once again. So times 15 plus 1.6 times live load, and our live load is 24 kilonewtons per meter. So times 24. And our answer here would be 56.4. So 56.4 kilonewtons per meter. So this is to be the value of our W. So the question is, which one would govern? Is it to be the first one or the second one? So can somebody give me the answer? So ano yung mas critical dyan sa dalawa by inspection? Guys, salit tayo sa Miss Baklili. Which one will govern?
Sir, yung second po.
Okay, very good. So the second will govern since mas malaki siya. And with that, guys, I will be deleting this already since you already know how to solve for them. And thus, this will be the governing one. So ito na yung governing factor natin. So equal to 56.4. So ito na yung ating W. And if you can see, guys, so ito, meron na tayong WU dito. So we already have our WU. And we will be multiplying it by our ln. And divide it by our coefficient. However, hindi pa natin alam yung Wn. I mean, ln, I should say. So, di pa natin alam yung ln. It is because that these distances are center to center. So, they are based from center to center. And for our ln, those are to be based from the length, I mean the clear span length. And if you can remember our lesson from before, for our clear span length, ito siya. So, hindi dapat kasama yung poste. So, if your center to center spacing is given, you must deduct the dimensions of the column. So, ayun. So, gawin natin yan. I'm sorry. So, in this one, guys, it is indicated here that the columns, so these are to be your columns, have a 0.5 meters dimension. So, 0.5 meters siya dito, 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 and dito. And with such, guys, if this is to be 6.5, we will be deducting half of 0.5 here. So, i-deduct natin tong half ng 0.5. Then, we will also deduct half of 0.5 here. So, with that, guys, for our ln1, so ln1, that is to be 6.5 minus 2 times 0.5 divided by 2. Teka. So, 0.5 divided by 2. Kaya ganito, kasi kalahati lang yung aalisin natin dito sa side na to. Then, kalahati din lang yung aalisin natin dito sa side na to. Thus, divided by 2. But we will be multiplying it by 2 since dalawa nga ang side sila. So, this one and this one. Okay, so solving for this would give you a value of 6 meters. So, kung ayaw nyo maniwala sa akin, let us solve for it using our calculator. So, that is to be 6.5 minus 2 times 0.5 divided by 2. So, 6 meters. So, with such, our ln for the first one, so ln is to be 6 meters. So, for the second one, so for ln2, so same old, so 7.5 meters minus half of this column and half of this column. And those are to be, so 2, 0.5 divided by 2. Thus, this is now to be 7 meters. And for our ln3, same old, so 5 meters minus 2 times, so 0.5 and 0.5. So, 0.5 divided by 2. So, however, if they are to be different, I mean, if the columns have different dimensions, hindi na ganito yung formula mo. So, ang formula nyo kapag magkakaiba na yung column dimensions is that, eto, then, column 1 lang. I'm sorry, teka, alisin ko lang sandali ito. So, minus half of column 1 minus half of column 2. That is if the columns have different dimensions. Pero para hindi na kayo mag-memorize, just remember that you are only solving for this particular length or the clear span. So yun ang galing lang sa face ng column up until the face of the column at the other part of the column. So yun lang yung isa-solve nyo. Thus, ito. So ito actually yung sinasolve natin ngayon. So anyway, 2, 0.5 divided by 2. So this is now to be equal to 4.5 meters. So with such, guys, so the ln here would be 7 meters. And the ln3 here is to be 4.5 meters. Okay, so malinaw ba guys? Is it clear on how we got LN1, LN2, and LN3?
Yes, sir.
Okay, very
Yes,
good.
sir.
Okay, so proceeding. So proceed na tayo. Teka, delete ko lang to. Ang kalat. Anyway, okay, so once again, what we should be doing is that we must solve for its moments. So I will just be copying this to our next slide para mas maayos yung solution natin. And I will be putting this here. So below our calculator para maayos and para kita pa rin. So there. Okay, so once again, what we will be doing here is that we will be solving for the shear and the moment of each segment. And if we are to draw its shear moment diagram, or let's pretend that we will be drawing the moment diagram first, it would be looking like this. So this point, so negative moment. Oops, sorry. Teka, mas maganda ito pag malaki. So negative moment, then ayaw talaga. Negative moment, then positive moment, then negative moment. So this is just an approximation, guys, no? So hindi kasi perfect yung pagdraw ko ng curve. So there, and so are there any questions, guys? Carl, question?
Napindot lang, sir.
Okay, it's okay. So anyway, so proceeding, no? So ito, negative, then positive, then negative, positive, then negative. So from the previous meeting, we already know how to get all of this. So let's start with the positive moments first. So for the positive moments, so it would be these ones. So it would be these ones. Teka. Ito. So we would be making use of this. And for the positive at the end span, positive moment at the end span, and by end span, those are to be our exterior beams or our exterior spans, it would either be this one or this one. So sabi dito, discontinuous and integral with support, or discontinuous and unrestrained. And as you can see in our example, the beams are to be restrained kasi merong columns dito. Oh. And since there are to be columns there, it means that we will be making use of this first, or WLN squared divided by 14. Okay, so with that, this is now to be 1 over 14. Teka, ibahin ko ulit yung color. So green na lang. So 1 over 14. And it is same is true with the other exterior span. So 1 over 14 din to. Kasi, well, basically magkapares sila. And as for this positive moment here, if we would be going back here, nandito na siya sa interior spans. So it would be that one. So kita ba guys? So guys, nakita ba yung fraction dito? And yung denominator niya? Mabasa ba?
Yes, sir.
Okay,
Yes.
so that is to be 16. So with that, 1 over 16. So this is to be its coefficient. So 1 over 16 na itong part na to. Okay, so we are already done with the positive moments. So now let us solve for the negative moments. So for the negative moments, so let's start here at this point. So if we would be going back here once again, itaas ko. Okay, so interior face of exterior support. So with that, by exterior support, that is to be the outermost column. And when we say interior face, ano pa ba yung Tagalog nun? Yung mukha niya sa loob ng building. So in this portion, guys, so if we have a column here, so if this is to be our column, this one is to be our exterior face, and this one is to be our interior face. So from that, guys, this is to be the one. So itong moment na yun. And dahil hindi ko man lang tinignan yung coefficient kanina, tignan natin ngayon. Okay, if that is to be for your interior face of exterior support, it would either be this one or this one. So mamili ngayon tayo. So it is said here that you will be using this if the member is built integrally with supporting column. And that is already the case for our case here. Kasi nga, may column siya. So, poste ito, no? Poste. And with such, yun, 1 over 16 na yung coefficient natin dito. So 1 over 16. And 1 over 16. So ayun yung sa dalawang yan. So let's go back. So by the way guys, paano ba ito? Itong integrally supported with span rail beam. So for example that this is to be your last span, I mean your exterior span. And let's say that this is to be interior column. So eto, if the support here is to be a beam instead of a column. So kapag column yan, ang gagamitin nyo, divided by 16, which is to be this. Pero kapag beam yung support dyan, so for example, this is to be a beam, you would be using WLN squared divided by 24. And as for that, guys, we will be having another example for it. But for this time, the basics muna. Okay, so anyway, so where were we? So meron na tayong interior face of exterior support. And how about for the exterior face of first interior support? So in our example, once again, these are to be our interior supports. Our first interior supports, no? Itong dalawang to. So ayun, for its exterior face, etong part na yun, eto. So eto exterior face. So pagpasensya nyo na, nabubulol ako ngayon. And this is to be the other exterior face of the interior support. Okay, so anyway. So ang sabi dito, if you have two spans, you will be using this. Nasa may laser pointer ko. So if you have two spans, you will be using this. And if you have more than two spans, you would be using this. And counting the spans here, so 1, 2, 3. So from that, it is to be more than two spans. So we will be making use of WLN squared over 10. So from that, guys, etong part na to, 1 over 10. And same is true with this part. So 1 over 10. Okay, so moving forward. So ito yung nag-govern kanina, no? So moving forward once again. Okay, so for the face of all other supports, we will be making use of WLN squared over 11. Okay, so with that, guys, this is now to be 1 over 11. So 1 over 11 na ito. And 1 over 11 din ito. Okay, so we are already complete with the moments. I mean, with the coefficients. So erase ko lang to para mas maayos. Hindi naman na natin kailangan yan. Anyway, guys, nababasa ba ng malinaw itong coefficients natin? Yung mga fractions?
Yes, sir.
Okay, very good. So what we will be doing right now is that we will now be applying our formula. So for our positive moments, so guys, ito pala may mga segments kasi dito. So meron tayong B. Meron tayong nomenclature for the points. So we have our B or yun yung midspan ng AC. Meron din tayong E and meron din tayong, teka, nakalimutan ko mag-assign dito. So H pala dapat to, then this is to be J. I pala I. Kalimutan ko na yung alphabet. Okay, ayaw ko na yan. Basta I yan. Okay. So for the positive moments, so positive moments. So for our positive moments, those are to be our MB, so moment at B, moment at E, and moment at H. So this one, and this one. So B, E, and H. And this is to be equal to, so W, L, N squared divided by 14, WLN squared divided by 16, and WLN squared divided by 14. So ito siya respectively. So 14, 16, and 14. Understood, guys?
Yes, sir.
Okay, how about for the other student not named Roxanne? Naintindihan niyo ba?
Yes, sir.
Yan, very good. Okay. So, yan, proceeding. So, proceed tayo, no? So, thank you, Miss Wansi and Mr. Banaag for responding. So, anyway, so, eto, equal sign. So, we will just be substituting known values. And for our W, it is to be this. Teka, nakikita ba sa camera? Okay, kita. So, 56.4. So 56.4 kilonewtons per meter times ln squared. And for your positive moments, basta ito lang yan. Kung ano yung nasa baba nila, yun na mismo yung ln na gagamitin mo. So with such, this is now to be 6 meters squared divided by 14. And for this one, this is to be 56.4 kilonewtons per meter times ln2. So that is to be 7. So 7 meters squared divided by 16. And this is to be 56.4 kilonewtons per meter times 4.5 meters. So etong part na to squared divided by 14. Okay, so now that I have already substituted them, i-move ko lang dito para may space yung answer natin. So the answer of these moments are to be, so looking once again at the calculator to your left. So sa una muna, sa MB muna, 56.4 times 6 squared divided by 14. So that is to be 145.0286. So 145.0286 kilonewton meter. So that is for the first one. For the second one, palitan lang natin yung denominator ng 16, then sa numerator part or yung ln ng 7 squared. So 7 times 7. O pwede din 7 squared. Kayo bahala. So 56.4 times 7 squared divided by 16, and that is to be 172.725 kilonewton meter. And for the last one, 56.4, palitan ko lang ulit yung denominator ng 14. So I would just be deleting 14 here, and I will just be changing the ln to 4.5. Tama. Okay. So this is now to be 81.5786 kilonewton meter. So these are to be for our positive moment. So guys, understood?
Yes, sir.
Okay, very good. How about for the others?
Yes, sir.
Yes, sir.
Okay, so very good. So proceeding, no? So itong positive moment, this is very basic. Actually, basic lahat. Medyo may catch lang tayo dun sa negative moment. So for the negative moment, so I would just be copying this to our next slide para hindi ko na i-redraw. So eto. Okay, so for the negative moment, so I would just be coloring it red. So negative moments. Okay, so for the negative moments, meron tayong catch dito. We will be multiplying this or its coefficient by WLN squared, but the LN should be the average of the two adjacent spans. So for example dito, no, sa una, so for MA. So MA. So this is to be equal to W. So nakalimutan ko yung W. Sige, copy-paste ko muna ulit para hindi natin makalimutan, no? So 56.4 kilonewtons per meter. So ayan. So W times LN. Ba't ko pa sinusulat? So 56.4 kilonewtons per meter times ln. And our ln, once again, is to be the average of the ln of two adjacent lengths. And in this case, ito yung isang length, and the other length is to be right here. However, since nasa dulo na to, 6 meters na lang to. Kasi wala naman siyang katabi. Pero kapag may katabi siya dito sa kabilang side, kukunin mo yung average nila. So, gawin natin yun mamaya sa MC. Ito yung MC, guys, ha. Anyway, so yan, squared divided by 16. So, this is to be its coefficient. And for MC, this is to be equal to, so 56.4. Di ko na ilalagay yung units, pero ayun. So, 56.4 times ln. And in this case, since our moment is to be located at this column, we now have two adjacent spans. So meron tayo yung 6 meters, then 7 meters. Kasi yung nasa gitna ng dalawang span na yan, yung kukuhanan natin ng moment. So with such, this is now to be 6 plus 7 divided by 2. Basta yung average lang nila. Or pwede din i-manual mo, no? 6 plus 7 divided by 2, that is basically 6.5. So pwede mong ilagay ng 6.5 dyan, pero let's leave it as is. So this is to be squared divided by, the coefficient here is 10. So 10. So once again, disclaimer, nabubulol ako ngayong araw, hindi ko alam kung bakit. Anyway, so moving forward for our MD. So MD is to be this one. So for MD, so same old, so 56.4 times 6 plus 7 divided by 2 squared divided by 11. Kasi 11 nga yung, yung, ang tawag dito, coefficient niya. Teka, nakita pa ba 11 dun sa baba? Ay, hindi na pala. So, teka, iurong natin lahat sa taas. For a moment. So, ayan. Okay, so, apologies. So, those are to be it. And solving for them. So, solve muna natin sila bago natin isolve yung other half. Oh, by the way, guys, since MA, so 1 over 16 yan. Ay, hindi pala pwede. Anyway, sige. Buray nyo yung sinasabi ko ngayon. So, ayan. Let's just solve for this. So, solving for that, this is now to be 56.4 times 6 squared divided by 16. So, yung unang moment natin is to be 126.9 kilonewton kilonewton meter, I should say. Then for the second one, 56.4 times the average of the two adjacent spans, so 6 plus 7 divided by 2 squared divided by 10. Okay, so this is to be 238.29. So 238.29 kilonewton meter. And for the other one, palitan lang natin yung denominator ng 11. So 216.27 kilonewton meter. So these are to be for your negative moments at this part. So for yung second half naman natin, no? For these ones, next slide na naman tayo at di nakasya. Pero copy-paste ko lang. So here, so we now have this. And we will be solving for the moments at this particular part. So yung 1 over 11, 1 over 10, and 1 over 16. So once again, napakadali nitong moments, ng itong procedure na to as long as you know how to interpret the table. And yung mahirap na part, ginawa na natin yun kanina, which is to interpret the table. Okay, so proceeding, guys. So for your moment at F, so MF, nakalimutan ko na naman. So 56.4, copy ko lang ulit. So 56.4 para lang natin makalimutan. So this is to be, so once again, W ln squared divided by coefficient. And in this case, yung coefficient niya is to be 1 over 11. So 56.4 times ln. And yung ln niya, guys, is to be the average of this and this. Kasi nga, yung moment na kinukuhanan natin is at this particular column. So kung ano yung nasa dalawang gilid niya or yung adjacent sa kanyang mga span, yun yung kukunin nyo ngayong average. So with such, this is now to be equal to 7 plus 4.5 divided by 2 squared divided by the coefficient, and the coefficient here is to be 1 over 11. So, multiplied by the coefficient. So, maging 1 over 11 to. And for RM, teka, urong ko nga lang to, nakaharang eh. Ayaw umurong. And for our moment at G. So, moment at G. Guys, pagpasensyan kung hindi mabasa, pero ito, G to. So, meaning that we are solving for the moment at this particular part. So, tignan nyo na lang yung laser pointer, gumagalaw siya. So, yan, and that is to be 56.4 times the average of both spans once again. So, that is, those are to be 7 plus 4.5 divided by 2 squared. And its coefficient is 1 over 10. So, divided by 10. And lastly, dito ko na lang isulat sa kabila. So, lastly, for our MI, itong part na to, yung last natin, for our MI, this is now to be equal to, asa na yun? 56.4 times the average of 4.5 and wala na. So, 4.5 lang. So, 4.5 squared. So, 4.5 lang at wala siyang partner kasi siya yung nasa pinakadulo. Kasi wala namang adjacent na span doon sa kabila. Understood? Why walang kasama si 4.5 kapag MI?
Yes, sir.
Okay, very good. How about for the others?
Yes, sir.
Okay, very good. So, ayan. So, proceeding guys. Our coefficient here is to be 16. So, 16 yung coefficient natin. So, divided by 16. So, with such, kunin na natin yung mga answers, no? So, for your MF, this is now to be equal to, so looking once again at the calculator to your left, so 56.4 times 7 plus 4.5 divided by 2 squared divided by 11. 169.52. 5205. So 169, sorry, 0.5025. So ayan, teka, delete ko na to para may space na naman tayo. Lagi ako nawawalan ng space and I need space. Yan. So kilonewton meter. And as for this one, so this is now to be, so 56 point, ba't ko pa dinilit yung kanina? Pares lang pala sila. Magkaiba lang sila ng denominator. So 56.4 times the average of 7 and 45 squared divided by 10. So this is now to be equal to 186.4725 kilonewton meter. So ayun, then delete na ulit natin to. And ayun. And lastly, for our MI, so urong ko dyan, lipat natin to sa baba. And getting the answer here, so this is now to be equal to, so eto, palitan ko ng 4.5 lang. Kakatamad mag-calcu. Okay, so malapit naman na. So 4.5 divided by 16. So 56.4 times 4.5 squared divided by 16. This is now to be equal to 71.3813 kilonewton meter. So this is to be our answers for the moment. So as you can see, kumpleto na natin lahat ng moments. So we already have our positive moments here. We already have the first part of the negative moments here and the last part of the negative moments. So basically, the next thing that we will be doing, that we should do for the detailing, for the summary, is for us to redraw this. Sige, asan ba yun? So copy ko lang to sandali. Then, ayan. And instead of putting our coefficients here, yung mga final answers na lang. Pero ang tagal. Pero ayan lang guys. So if you already have your negative moment MA, so what you will be doing is that you will be labeling this. So ito. 126, negative 126.9. Then for your MB, positive 145.0286. So 145 point, nakalimutan ko na, and so on and so forth. Basta ilalagay na lang dito yung mga nasolve mong mga moments. Okay, so those are to be for your positive and your negative moments. But what about for your shear? So yung shear natin is to be much more simpler, no? So meron lang tayong dalawang condition. So for your shear, it would be this, and it would be this. So you will just be multiplying it by 1.15. So 1.15 WLN divided by 2 if you are solving for the exterior face of the first interior support. And for all other supports, WLN over 2 lang yan. So with such, so exterior face of first interior support. So with that guys, ang coefficient natin sa part na to, mag-drawing ulit tayo. So dito na lang ulit. So erase ko na muna ito, yung mga moment natin. So alisin ang mga moment. Yan. So for its shear, so ito pataas to. So meron tayong shear dito. Meron tayong shear dito. Hindi na shear diagram ito drawing ko, yung mismong shear na guys. So ito shear. Basta sa lahat ng corners meron tayong shear. So wala lang tayong shear dun sa midspan. Puro sa mga supports yung shear natin actually. And in this case, sabi sa provision kanina, pag exterior face of first interior support, dito daw is to be, so dito sa part na to, that is to be 1.15 times WLN divided by 2. And ganun din dito sa part na to. Basta sa dalawang sides ng sa exterior face of the first interior support. So ayan siya. And for all the other supports, WLN over 2 na lang yan. So ito WLN over 2. Ito din WLN over 2. And ito din WLN over 2. So ayan lang yan. And solving for them, so dito na lang sa baba ilagay. Pero urong natin lahat. So solving for them, for exterior face of first interior support. So this is to be, so 1.15 times WU, and yung WU ulit natin is to be 56.4. Kalimutan ko lang. So 56.4 times LN, and our LN, ito, kapag sa shear guys, hindi na tayo mag-average. Automatic na kung nasaan span lang siya. And in this case, dito sa una, 6 meters, yung sa pangalawa, 4.5 meters. So dito, 6 meters. Then yung isa, 1.15. Teka, ang gulo. Sige na, isa-isahin na nga lang natin. Ang gulo pala pag ganito. So this is for WA sa part na to. WC. So ito, WC. Ito muna i-solve natin. For WC, this is to be 1.15 times 56.4 times 6 meters divided by 2. So ito, direct sub. And as for our WG, itong sa kabilang part naman, WG is now to be equal to 1.15, erasin na natin to, times 56.4 times 4.5. So ito yung span niya. So 4.5 meters divided by 2. So solving for them will give us an answer of, so 1.15 times 56.4 times 6 divided by 2. So our answer here is now to be equal to 194.58 kilonewtons. And our answer for the next one is to be 4.5. Is to be 145, I should say. 145.935 kilonewtons. Okay, so ayun, delete ko na lang ulit to para may move natin to. So those are to be for WC and WG. And for all other supports, so sa lahat na ng natira, so from WA, WD, WF, and WI, we will be using this one only. So, WLN over 2 lang. So, for WA, for WD, WF, and WI. So, ito lang siya. So, move ko lang pataas. So, sorry at medyo limited kasi yung space natin kaya pinagkakasya ko na lang. No? So, ito, this is to be, ano ulit yung W? Nakalimutan ko na. 56.4. So, 56.4 times ln, and that is to be 6 meters in this case. Ito, 6 meters divided by 2. So, gano'n na din sa lahat. So, 56.4 times ln, and if WD is to be here, so 7 meters yan. So, 7 meters divided by 2. And yung WF natin, parehas yan. So, 56.4 times 7 meters divided by 2. So, kapag nabibilisan lang kayo masyado, sabihin nyo lang sa akin, no? Pero ito, direct substitution na lang. So, for your WI, or ito, that is to be 56.4 or W times ln, and ang length natin dito, or span length natin is to be 4.5. Then, divided by 2. So, solving for all of this. Sige, mabilis ang solve. So, 56.4 times 6 divided by 2. So, 169.2. Then, as for the second and third, $197.4. Then, as for the fourth one, $126.9. So, basically, that is how you would be solving for them. So, may idea na kayo kung ano yung lalabas sa exam, no? So, ganito yung mangyayari sa exam. It's just that I will be requiring you to summarize your answers. Ito kasi hindi ko sinamarize, no? Kasi medyo nahirapan nga ako mag-drawing digital, lalo na nag-drawing ako dito sa baba, then nakatingin ako sa screen. So, medyo nahirapan ako mag-drawing. And anyway, so, for the next step is that gagawa nyo na siya ngayon ng ng moment diagram, just like this. Then, labelan nyo yung bawat parts ng moment diagram na na-solve nyo. Then, ayun, that is to be it. So, basically, guys, once again, that this is to be what we would be calling simplified method of analysis. But if you would be asking, are the values here accurate? So, the short answer to that is not quite. So, hindi talaga siya accurate because it is said here that this is just approximations. So, approximate moments for non-prestressed continuous beams and one-way slab. So, once again, approximation lang yung nangyayari kasi dito. Pero meron namang factor of safety, but soon enough, if you want to have a more accurate work, isolve nyo siya using any method, just like your moment distribution, your slope deflection method. So, if you have your Excel, pwede nyo namang gawan ng program yon. And maybe, if you want, if you are already engineers, you can use softwares. Pwede mag-STAAD, pwede mag-ETABS, pwede mag-MIDAS, kahit ano. So, mas accurate yon. So, once again, this result will give you a not so accurate result, but that will suffice. So, medyo may onting factor of safety tayo dito. Okay, so anyway, so supposedly, I will still be explaining another lesson here. Pero 2:17 na. And we only have 13 minutes. So, ito kasi medyo matagal. So, I will just be giving you pointers pa paano ba ito gawin. Okay. So, the first thing that you will be doing here is for you to solve for the loads. So, solve for loads. So, in this case, we have our dead load and we have our live load. But for our live load, given na siya. So, 2.4 kilopascal. And yung sa dead load, madami kayo kapang i-compute. So, ito, ang mangyayari lang dito is volume times the unit weight. So, for example, you want to solve for the, for the weight. Teka, na oras na ba? So for example, that you are solving for the weight of the beam, then you will just be multiplying the area here, I mean the volume or the area by the unit weight. So ayun, so ang kalalabasan dito is to be in terms of kilopascal. So x, kunwari, kilo pascal. So kunwari may masolve kang masolve kang a value dyan. But the thing is, di ba sa approximate method natin, they are to be in terms of kilonewtons per meter. So now, how can we convert this pressure into line load? So, copy ko lang ulit dito. So once again, how to solve for the line load if you are to be given pressure. So when we say pressure, they are to be in terms of force per unit area or kilopascal. So kapag pressure kasi guys, you are to be assuming that the load is to be acting at a certain area. So for example, yung pressure sa lahat ng to, no, ito pala guys is to be a top view. So top view ito guys. And ayun, so plan. So kung nakikita nyo dito, so the ones that you are seeing here, so these red dots right here are to be your columns. And these white lines right here are to be your beams. So ngayon, ulitin ko lang, paano ba natin maiko-convert ng line loads ang pressure natin? So if you can remember our lesson from before, that we will be making use of the tributary area method. But before we would be making use of that, we would be checking first if our beams here are to be one way, or I mean, if our slabs here, sorry, once again, ulitin ko, i-check natin ngayon if yung slab natin dito, if it is to be one way or two way. Kapag one way, pwede natin gamitin yung tributary area method, pero pag two way kasi medyo mas mahirap na siya. Hindi agad yung tributary area method yun, no? So anyway, so let us check. So check if one way or two way. So once again, what we will be doing is that we will be dividing the short span divided by the long span, and we will be comparing it with 0.5. If it is to be less than or equal to 0.5, then meaning it is to be one way. And if it is to be the other way around, two way siya. So okay, check natin to. So in this guys, our short span is to be, so ito kasi guys, ito yung isang area, ito yung isang area, ito yung isang area, itong isang area, and so forth. And since all of them have the same dimensions, so 2.7 divided by 7.15 lang yan, so one solution would suffice. So with that guys, this is to be 2.7 meters divided by 7.15 meters. So ngayon, this is now to be equal to, so 2.7 divided by 7.15, oops, sorry. It is now to be equal to 0.378. So 0.378. And as you can see, this is indeed less than or equal to 0.5. So eto. So with that guys, we can now conclude that in our system, it is to be a one-way slab. So guys, understood kung bakit one-way slab siya?
Yes, sir.
Yes,
Very
sir.
good. Very good. Okay. So how about for the others, aside from Mr. Abdon and Roxanne? Understood?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, very good. Okay, so when we say one-way slab, kung naalala nyo, actually third meeting na natin pinag-usapan ng one-way slab. Pag one-way slab, isang direction lang, I mean, isang line direction lang yung pinupuntahan niya. Magkabilaan lang. So in this case, guys, if this is to be your slab, for example, this area, pag maglalagay ka dyan ng load, ang pupuntahan niya lang is dito. So, dyan, pati dito. So, dyan, dito, and if in this case, dyan, then dito, dito. So, hindi siya pupunta sa right and left. So, hindi siya pupunta dito sa mga maliliit na beams. Doon lang siya sa malalaking beams pupunta. So, that is for your one-way slab. And if your slabs are to be one way, dito tayo pwede ngayon gumamit ng tributary area method. So once again, when you see tributary area, it is to be the area that is being carried by the beams that you are analyzing. So for example, guys, you are analyzing this beam. Teka, hindi nakikita yung dinodrawing ko. Teka. So for example, guys, that this is to be the beam that you're analyzing. So guys, nakita nyo ba yung dinodrawingan ko ng red?
Yes, sir.
Yes, sir.
Okay, so for example, yan yung ina-analyze natin ngayon. So for example, that is to be the beams that we are to be analyzing. We are to assume that it is to be carrying half of this area here and also half of this area here. So kumbaga, kung umapa ka dyan sa area na yan, it is assumed that that the beams that are carrying you are to be beams GHI. So eto, basta nandyan ka sa area na yan, ang nagbubuhat sa'yo is yung beam GHI once again. And if this is to be 2.7 meters, so kung 2.7 meters yan, this dimension is to be the half of 2.7 as well as for this. So 2.7, 2.7. So 2.7 over 2 and 2.7 over 2. So ayan. But for example, guys, na magkaiba yung dimension. So for example, that this is to be the beam that you are analyzing. Then dito mas malaki, then dito mas maliit. For example lang. So your tributary area, guys, is to be half of this. So kalahati ng dimension dyan. And kalahati din dito. So kung nakita nyo, tabingi siya. Pero wala, ganun talaga. So ganyan yung tributary niya, guys. So in other words, if you are to be analyzing this beam, it would carry this area. Okay. So with that, guys, so if that is to be the area, so for your pressure load, since naka kilonewtons per square meter nga siya, or this one, so naka kilonewtons per square meter siya, para i-convert natin siya into line load, we will be multiplying this by the tributary width. And the tributary width is this particular width. Or in this case, 2.7 divided by 2 plus 2.7 divided by 2. And yun, para mas malaki lang, no? So kung ito yung beam natin, ito yung tributary width sa kabila, ito yung tributary width sa kabila. So dito, 2.7 over 2 and ito 2.7 over 2. So if you would be adding them, the whole of it, itong tributary width na yan, the whole of it would be 2.7. Kasi 2.7 over 2 plus 2.7 over 2, so that is to be 2.7. So in this case, guys, you will now just be multiplying this by 2.7 meters. So meters would cancel out. And you will now be arriving at a line load. So meron na kayong W. So ayun, guys, and it is better if you would be segregating your dead load and your live load first before converting them into line loads. So for example, ang pressure mo dito is ito yung WDL. DL lang pala, ito yung pressure. Then nung minultiply mo siya ngayon sa tributary width, ito na yung WDL mo. And for your WLL, ganun din. 2.4 kilopascal. Kasi itong live load natin given na. So 2.4 kilopascal multiplied by tributary width of 2.7. 2.7 tayo. So with that, guys, our line load here is to be 6.48 kilonewtons per meter. And as for the dead load kasi, hindi pa natin alam yung pressure kasi kulang nga tayo sa oras at hindi natin na-solve yung pressure ng dead load. Pero since given naman na yung live load, edi ayun. Ito na agad yung live load natin na W. And once that you already have your WDL and WLL, mag-load combination ka na lang ulit, then gawin mo ulit yung ginawa natin kanina. And if you are to analyze, let's say, kunwari, JKL, so for example, you are analyzing the beams JKL, it would be looking like this. Ito yung nasa gilid niya. So meron tayong column sa baba, sa gitna. Then sa dalawang sides wala tayong column pero nakakabit siya sa beam. Pero for example, ang ina-analyze nyo is GHI. It would be looking like wala. So it would be looking like this. So meron tayong column, meron tayong beam, Then we also have our column, our beam again, and our column. And if you already have this, gamitin nyo na ulit yung simplified method, then you already know the required strength of your members, which are to be yung MU tuloy. Oo, tama, MU doon sa ating analysis proper itself. So, ayun, sagad, 228. So, guys, are there any questions? Understood? Miss Wansi, questions or naintindihan?
Naintindihan po, sir.
Okay, very good. Roxanne.
Understood, sir.
Okay, very good. Chandni. Chandni, nariyan ka ba?
Yes, sir. Understood.
Okay, very good. Frederick, understood?
Yes, sir.
Wilmel, understood?
Yes, sir.
Okay, very good. Nemius, understood?
Yes, sir.
Okay, very good. So with that, guys, I will now be ending the recording. So end ko lang